Hi guys, so today we're going to be deriving the equation of motion for this pendulum using the Lagrangian. So first of all, what's the Lagrangian? It's just simply L equals to T minus V, where T is the kinetic energy and V is the potential energy. So now T, which is the kinetic energy, is stored by the mass, will be half mv squared. But in this case, velocity will be represented as x dot squared. Now, this pendulum is swinging in a circular motion, but this particular velocity is linear velocity. So the formula for linear velocity in the case of a circular motion is half m L, which is the radius in this case, times the angular velocity. You can go online and just check formula for linear velocity. You see R times W, where W is theta over time, which can be represented as x dot. Now don't forget your squared. I always forget it. So the potential energy in this case is gravitational. So it's going to be mgh. In this case, h is y. That's the height. But notice that the pendulum is swinging in the negative direction of y. So we're going to have minus here. Now using Pythagoras theorem, you can tell that the y presented as L cos theta. So it will be minus mg L cos theta. Simply writing out the Lagrangian, we have half m L dot squared plus minus minus mgl cos theta. Now that we have this, we can write the Euler Lagrangian formula, which is giving us d over dt, differential of the Lagrangian with respect to theta dot, yeah, minus differentiation of the Lagrangian with respect to theta, which is equals to 0. Now, using this equation, we're simply just going to differentiate everything accordingly. First, we take the differential of the Lagrangian with respect to the angular velocity. So we expand it. If you expand it, you're going to have half m L squared theta dot squared. Now note that this is a partial derivative, so anything that does not have theta dot will be treated as a constant. So we're only going to be differentiating this. If you have to differentiate, this 2 will come down, multiply here, leaving this as 1. So we're going to have ml squared theta dot. Now differentiate this with respect to time, that's d over dt of ml squared theta dot. We're going to simply have ml squared theta dot dot. We're differentiating with respect to time. This theta dot is the theta dt. If we differentiate this with respect to time, we're going to have the square theta over dt. Next, we're going to be taking the derivative of the Lagrangian in respect to theta. Only this part of the equation will be affected. Now, to write out the final equation, we're going to first write this, which is ml square theta dot dot minus, but to be minus minus, so we just make it plus here, mgl sine theta equals to 0. This is our final answer, although we can simplify this. If you factor out ml and divide it on both sides, it will cancel out, leaving you with theta dot dot plus g over l sine theta equals to 0. And this is our final answer, guys. So hopefully you understand, and don't forget to like and subscribe and leave your questions in the comments.